Hello viewers, in today's class we are going to discuss one very important and conceptual limit from limits and continuity, right? So here we have to find the value of this limit involving the fractional part function, right? So let us start, and here what we will do, we have limit extends to 2 and fractional part of 2 minus x plus fractional part of x minus 2, right? So we'll find out the right hand limit and the left hand limit, right? And if both the limits exist and they are finite and equal, then we can say that the limit of this function when x tends to 2, it exists, right? So now let us first find out the right hand limit, right? So we'll denote the right hand limit by RHL, and here we'll write this notation, that is limit x tends to a plus, and here we have f of x, right? So now here the value of a can be taken as 2 because here x tends to 2, and for f of x we can take this function, that is fractional part of 2 minus x plus fractional part of x minus 2, right? So now here we have limit x tends to 2 plus, and we have a fractional part of 2 minus x plus fractional part of x minus 2, right? So now to move further, what we will do, here we'll substitute x is equal to 2 plus h, right? Because see, we are finding out the right hand limit, and here we have x is equal to 2 or a is equal to 2, and we are approaching towards x is equal to 2 from the right of x is equal to 2, right? So we'll take x is equal to 2 plus h, where h is a positive quantity and h lies between 0 and 1, and moreover the value of h is very very small, right? So now when x tends to 2, obviously h tends to 0, right? So now the right hand limit can be written in terms of h as the limit h tends to 0, and here we have fractional part of 2 minus x, so we'll take x is equal to 2 plus h. So here we have 2 plus h, and here we have 2 plus h for this x, and here we have minus 2, right? So now we can simplify this expression. So we have limit h tends to 0, and here we have a fractional part of 2 minus h, and here we have 2 plus h minus 2, right? So now this 2 and this 2 get cancelled. Similarly, this 2 and this 2 get cancelled, and we are left with the limit h tends to 0, and here we have fractional part of minus h, and here we have fractional part of h, right? So now here we have a limit h tends to 0 and the fractional part of minus h plus fractional part of h, right? And remember, here we cannot directly substitute h is equal to 0, right? So what we will do here, we'll make use of the definition of fractional part function. Now we know that the fractional part of say x is defined as x minus greatest integer of x, right? So here we have fractional part of minus h. So now the right hand limit, it can be written as the limit h tends to 0, and for fractional part of minus h we can write minus h, and then we have minus of greatest integer of minus h, right? So here in this definition we have substituted x is equal to minus h. Now here we have fractional part of h, so this can be written as h minus fractional part greatest integer of x, right? Now this h and this h get cancelled, so we are left with limit h tends to 0, and here we have negative of greatest integer of minus h, and here we have minus greatest integer of h, right? So now here also we cannot directly substitute h is equal to 0, right? So what we will do here, will make use of the definition of this quantity h, right? So now see, h lies between 0 and 1, right? So h lies between 0 and 1. So this implies that the greatest integer of h must be equal to 0 by definition of greatest integer function, right? Because h is a very small quantity and it lies between 0 and 1. So the greatest integer of h must be equal to 0, right? So here we have the quantity 0. Now we have to decide the value of greatest integer of minus h, right? So for minus h, what we will do, will multiply this inequality throughout by minus 1. So what we will get, will get 0, and the direction of the inequality get reversed. So here we have minus h and here we have minus 1, right? So now this inequality can also be written as minus 1 less than minus h, and here we have less than 0, right? So now this inequality shows that minus h, it lies between minus 1 and 0. So by the definition of greatest integer function, the value of greatest integer of minus h must be equal to minus 1, right? So we can take it as a formula that always the greatest integer of h is 0, and the greatest integer of minus h is equal to minus 1, right? So here we can take minus 1. So now the right hand limit, it becomes limit h tends to 0, and here we have minus 1. So here we can write minus 1 and here we have 0. So this is minus minus plus, and now we can remove this limit notation, because here we do not have any term containing h. So we have 1 minus minus plus, so we have plus 1 minus 0, that is equal to 1, right? So the right hand limit of this function f of x when x tends to 2 is equal to 1, right? So now let us find out the left hand limit, right? So the notation for left hand limit is the limit x tends to a minus, right? So here this negative sign shows that now we are approaching towards x is equal to 2 from the left of x is equal to 2, right? So now here we have f of x. So this is limit x tends to 2 minus, and for f of x we can write the fractional part of 2 minus x, and here we have fractional part of x minus 2, right? Okay, so now to proceed further, what we will do, we'll take x is equal to 2 minus h, right? So for finding out the left hand limit, we'll take x is equal to 2 minus h, and the other conditions remains the same, that is h is positive and it is very small, and h lies between 0 and 1, and moreover the greatest integer of h is equal to 0 and greatest integer of minus h is equal to minus 1, right? So now this limit can be written in terms of h as limit h tends to 0, and here we have the fractional part of 2 minus, and now we have here for x we can write 2 minus h, and then we have here 2 minus h, and this is minus 2, right? Okay. So now let us simplify this expression. So we have limit and h tends to 0, and here we have greatest the fractional part of 2 minus 2, and here we have plus h, and then here we have this 2 and this 2 get cancelled, so we are left with minus h, right? So now this 2 and this 2 get cancelled. So we are left with limit h tends to 0. And here we have fractional part of h plus a fractional part of minus h, right? So now the left hand limit can be written as here we have limit h tends to 0, and here the fractional part of h can be written from this result. So we have h minus the greatest integer of h plus here we have the fractional part of minus h. So we can write minus h minus greatest integer of minus h, right? So now this h and this minus h get cancelled. So we are left with the limit h tends to 0 minus of greatest integer of h. And here we have minus greatest integer of minus h, right? So here also we cannot directly substitute h is equal to 0. So what we will do, we'll take help of these two results, right? So when h tends to 0, the greatest integer of h is 0. So here we have 0, and the greatest integer of minus h is minus 1. So now we can remove this limit notation. So we have minus 0 and minus minus plus, so we have 1, right? So the left hand limit is also equal to 1. So viewers, from this discussion, we have arrived at this conclusion that the right hand limit is finite and the left hand limit is also finite, right? And both the limits exist when x tends to 2, right? And moreover, the right hand limit is equal to the left hand limit, and both the limits are equal to 1. So we can safely claim that limit x tends to 2 of this function f of x is equal to 1, right? So the limit of this function when x tends to 2 is equal to 1, right? Now it is interesting to find out the value of f of 1, right? So here if we take x is equal to 1, then we can write the values of f of 1. So we have the fractional part of 2 minus 1, then we have fractional part of 1 minus 2. So here we have taken x is equal to 1. So now this is fractional part of 2 minus 1 is 1, and here we have a fractional part of 1 minus 2, that is minus 1, right? So now to find out the value of fractional part of 1, we can take the help of this definition. So we have 1 minus the greatest integer of 1, and here we can write minus 1, and then minus the greatest integer of minus 1, right? So this is 1 minus greatest integer of 1 is 1. Here we have minus 1, and here we have greatest integer of minus 1, which is minus 1 itself, right? So this is 1 minus 1 minus 1, and this is plus 1. So this is 1 minus 1 is 0, 1 minus 1 is 0. So we have 0, right? So the value of f of 1 is equal to 0.